day, dear viewer. I welcome you to today's class. I'm Nwachukwu Daniel. Today, we'll be discussing correlation and regression. What is correlation? What is regression? These two terms are statistical techniques we have. Correlation simply means a statistical technique that tells us if there is a relationship between two variables. If there is a relationship between Obi and Ada, if there is a relationship between Y and X, that is what correlation tells us. Then regression tells us the extent or the degree of relationship that exists between two variables. To what extent do that relationship exist? Now, this correlation and regression can be represented in a graph or diagram. This diagram is called scatter diagram or scatter plot. And look at how the graph looks like. So you can see that the points are in a scattered form. Now, there are different types of correlation. 1, positive correlation. 2, negative correlation. 3, zero correlation. And 4, nonlinear correlation. Let's see how they look like. This one is a positive correlation because if you look at it, it moves towards positive slope. Then, remember this graph of Y against X. Now, this one is negative correlation, moving down. Now, this one is zero correlation. This is negative. This is zero correlation graph. Say graph of Y against X, Y against X. Now, for nonlinear correlation, it looks this way, or it looks this way, or it looks this way. These are typical examples. These are typical examples of non-linear correlation. Non-linear simply means it's not a straight line graph. It's a curved graph. Now, in correlation and regression, after plotting a graph of correlation and regression, and you have a positive graph, for instance, you can see that you will draw a line of best fit. This line you see we draw is called regression line, or line of best fit, or least square line. That is the name of this line. Since every line has an equation, we have general equation for a straight line, and that is y equals to ms plus c. This is when y depends on x. Where you plot graph of y against x. After plotting graph of y against x, here will be called, this m will be called the slope, while the c will be called the intercept on the vertical axis. Now, if it is graph of, if s depends on y, the equation will be x equals to my plus c. This is where s depends on y. S equal to my plus c. Where the s, the graph will now be plot x against y. Then m will be the slope, c will be the intercept on the vertical axis. Then, how can we get the slope of this graph? can we get the intercept on this graph? Take for instance, if we are plotting y depends on x, that is graph of y against x, for instance, the implication is that slope will be equal to m and is equal to summation of x, y minus m mean of x, mean of y, all over summation of x squared minus m mean of x squared. This is one of the formulas you can use to get this slope of graph of y depends on x. Another formula you can use is m equals to m summation of xy minus summation of x summation of y all over m summation of x squared minus summation of x all squared. Another formula you can use to get this slope is m equal to summation of x minus mean of x, y minus mean of y, all over summation of x minus mean of x all squared. All these will give you the same answer. This is used to get the slope of the graph. Now you only use one of the formula. Then this is for slope. I will have another one, intercept on the vertical axis. The vertical axis could be y, the vertical axis could be anything. Now you say the intercept C is equal to mean of y minus m mean of x, because we are talking about y depends on x. So intercept on the vertical axis will be mean of y minus m mean of x. Now we want to see how we can determine all these parameters, but when we go to the question, we see how to get all of it. After you get the value of your C and value of your slope, when you put it into this value, into this equation y equal to ms plus c, what you'll be getting is the equation of the straight line. Since the equation of a straight line is y equals to ms plus c. Now, another thing that we also want to learn from this topic is how to get the correlation coefficient or coefficient of regression. How do we get correlation coefficient or coefficient of regression? There are two major ways you can get this parameter called correlation coefficient or coefficient of regression. One of the ways is called product moment correlation coefficient, PMCC. Product moment correlation coefficient. Another way you can get it is through specimen rank correlation coefficient method. Specimen rank correlation coefficient method. Now, how do we use product moment correlation coefficient? It has formula. One, you say R is equal to summation of sy minus m mean of s mean of y all over square root of bracket summation of x squared minus m mean of x squared and summation of y squared minus m mean of y squared. Okay, then another formula you can use is say m summation of sy minus summation of y summation of x all over square root of m summation of x squared minus summation of x all squared. Then n summation of y squared minus summation of y all squared. Another formula you can use is say r equal to summation of x minus this bracket y minus this all over summation of square root of summation of x minus this all squared and x y minus this all squared. So these are the formulas you can use. All of them will give you the same answer in one decimal place. Now this correlation coefficient or coefficient of regression we are trying to determine tells us the extent of relationship in terms of figure. It tells us the extent of relationship and it has a range. But before we go into the range, let's see the one of Spearman rank correlation regression. Spearman rank correlation coefficient. It has a formula, and the formula is y minus 6 summation of d square all over n bracket f square minus 1. Where the d is the difference between the rank of the x and the y. So when you get it, you call your d and square it. Now, we want to see how to interpret results from correlation coefficient we have calculated. We can be asked to calculate it, interpret it. See how to interpret it. Note that the correlation coefficient R has a range. R greater than or equal to minus 1, less than or equal to 1. These are the two range of this correlation coefficient. That is to say, when it is at 0, what you will say is that it is 0 correlation. 0 correlation simply means there is no relationship between the two variables we are talking about. Now, from here, this is positive axis and this is negative axis. Here is 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Y here is minus 0.1, minus 0.2, minus 0.3, minus 0.4, minus 0.5, minus 0.6, minus 0.7, minus 0.8, minus 0.9, minus 1.0. So these are the description of the correlation coefficient. Now, when you have after calculating this correlation coefficient with any of this formula we just listed, and you get 0, the implication is that there is no relationship between the two variables. Then, when you finish calculating it and it falls between 0.1 to 0.3, the implication is that it is low, there is low positive correlation. Then, when it is between 0.4 and 0.6, the implication is that there is some positive correlation. Then, when it is between 0.9 and this, the implication is that there is high positive correlation. Then when it is 1, the implication is that it is perfectly positive correlation. Then when it is between this minus 0.1 to 0.3, you say it is low negative correlation. Then when it is between 0.4 and 6, we say there is some negative correlation. And also, when it is between 0.7 minus 0.7 to 0.9, you say there is high negative correlation. Then, when it is at minus 1, you say that there is perfectly negative correlation. So these are the interpretation of the correlation coefficient or coefficient of regression you will get. Remember that this R that has this value ranges between minus 1 to 1. So R is greater than or equal to minus 1, less than or equal to 1. Okay? Now, this is for correlation coefficient or coefficient of regression. We want to see coefficient of determination. How do we calculate coefficient of determination? Let's see how to do it. It has formulas. For coefficient of determination, it is noted as R squared. Then is equals to L summation of x, y minus summation of y, summation of x, all squared, all over n summation of x, y minus summation of x, all squared, bracket n minus bracket n summation of y squared minus summation of y all squared. Then it also has this formula to be summation of sy minus n mean of x mean of y all squared all over summation of x squared minus n mean of x squared, then summation of y squared minus n mean of y squared. So you can use any of these two methods to get it. Remember, we want to see some calculations on this. You look, see the board. You see, the question said the table below shows the scores of 5 students in maths and physics. And they indicated that maths is x, physics is y. They say if y depends on x, find the slope and intercept on vertical axis. Equation connecting y and x. Find its correlation coefficient and interpret or comment. Find the coefficient of determination. Let's see how to get it. After plotting this graph, you can use the graph to answer all these questions. But if you don't have time to use the graph to answer it, you can use formula method and answer it correctly well. Now, let's use formula method and answer it since we don't have a graph sheet here. Now, for formula method, they say we should get the slope. We say, since they say y depend on x, y depend on x, it implies that y equal to ms plus c, as we said earlier on, where y is plotted against that is the physics, is plotted against mathematics. So this m will be the slope and the c will be the intercept. Now the slope will be gotten from summation of x, y minus m, mean of x, mean of y, all over summation of x squared minus m mean of x all squared. That is to say, we just pick one of the formulas we listed. Now, how do we get all these parameters? Let's draw our table. This is your x, this is your y, this is your x squared, this is your y squared, this is your xy. Then, you now say, what are values of x we have? Values of x we have are 2, 5, 3, 5, and 4. What are values of y we have? Values of y are 4, 6, 4, 3, and 1. So, x squared means square all the values of x. We have 2 squared 4, 5 squared 25, 3 squared 9, 5 squared 25, 4 squared 16. Then, what are values of y? You can see it here. Then we now say 4 squared 16, 6 squared 36, 4 squared 16, 3 squared 9, 1 squared 1. Now, xy means multiply the x and the y. 2 times 4, 8. 5 times 6, 30. 3 times 4, 12. 5 times 3, 15. 4 times 1, 4. Okay? Now, what you do, you say, can you get your mean? Your mean is equal to summation of x over n. What are the total number of x? 2 plus 5, 7, plus 3, 10, plus 5, 15, plus 4, 19. Summation of x equal to 19. It implies that 19 all over, how many are there? 1, 2, 3, 4, 5. 19 over 5 will be giving you 19 over 5 will be giving you 3.8. Then, mean of y is equal to summation of y all over n. And what is the total for y? 10, 14, 17, 18. Summation of y equal to 18. So we say 18 all over 5 because we have 5 values. So that will be giving you 3.6. Okay? Now, you now say summation of xy. 8 plus this is 38. 38 plus 12 will give you 50. 50 plus this will give you 65. 65 plus 4 will give you 69. You say summation of xy equal to 69. Now, you put them inside the formula. We now say that your slope m is equal to summation of sy. What is our sy? 69 minus, what is our n? 5 times, what is our mean of x? 3.8 times 3.6 all over, what is summation of s squared? Now let's add s squared. If you add this s squared, what you'll be getting is summation of x squared equal to 79. Now what is summation of y squared? You say summation of y squared equals to 16 plus this, 52, 52 plus this, 68, 68 plus this, 77, then 78. So we have 78 as our summation of y squared. Then we put what we have to this. Summation of s squared is 79 minus n is 5 times mean of x squared is 3.8 squared. So when you finish computing this, you will be getting 0.088. Just say 5 times this, 69 minus 6, 79 minus 5 times this squared. Use your calculator and you'll be getting 0.088. This means that this is your slope. And this also means that since it is positive, it is a positive correlation. That is, the slope is positive. Now, we want to get the intercept on the vertical axis. The intercept on the vertical axis. We said the intercept means C equals to the mean of y minus m mean of x. What is mean of y? It is 3.6. Then minus m means 0.088 times what is the mean of x? 3.8. So when you compute this finish, you will be getting 3.27 approximately. This simply means that if this is the graph, this line of best fit or regression line must cut through 3.27. So 0, 1, 2, 3. The intercept of it should be at this point. So we now say the graph will go this way. So meaning that it will cut the y-axis at 3.2, and the slope must be in a positive way. That is plus 0.088. Now we have gotten the slope and the intercept on the vertical axis. The implication now is that since the equation of the graph is y equals to ms plus c, we will now say that the equation of this line of best fit will be equal to y equal to what is our slope? 0.088x plus what is our intercept? 3.27. This is the equation connecting y and x, where this is the slope and this is the intercept on the vertical axis. Now we've been able to get the slope, the intercept on the vertical axis, and the equation of the graph. Now, what we want to get now is the correlation coefficient. Now, to get the correlation coefficient, we now say, remember our formula R equal to, we take one of the formula, which says summation of sy minus mean of x mean of y all over square root of summation of x squared minus m mean of x squared. Then bracket summation of y squared minus m mean of y squared. Now, we want to compute the parameters we have. Summation of sy gave us 69. We say 69 minus n means 5. We say 5 times mean of x means 3.8. 3.8 times mean of y is 3.6. 3.6, okay? All over. Now, summation of x squared. Summation of x squared is 79 minus n means 5. Mean of x mean 3.8 squared. Then we now say summation of y squared is 78 minus n is 5 times 3.6 squared. So when you compute the numerator, you will be getting with a good calculator. When you say this times this minus it from 69, you will be getting 0.6 all over. Then when you compute this and this, you will be getting square root of this times this with a good calculator. When you compute this with a good calculator, you will be getting that your R will be giving you 0.1 approximately. Just use your calculator, press 5 times 3.8 times 3.6, and also from this, keep. Then 79 minus this times this times this, then 78. This times this minus it from 78, then multiply the 2. After multiplying the 2, get the square root of it. Then use it to divide the numerator. After dividing it, you'll be getting 0.1 approximately. Now, the answer you got here simply implies that it falls in this range from 0.1 to 0.3, and that means that the relationship R will be low positive correlation. Then, we want to see how we can determine the coefficient of determination. Coefficient of determination. Then, the coefficient of determination R squared is equal to summation of x squared, summation of xy minus m, mean of x, mean of y, all squared, all over summation of x squared minus n, mean of x squared, bracket summation of y squared minus n, mean of y squared. Then all you just need is to carry these parameters we have, put it here, and use a good calculator to compute it. We say r squared equal to, let's put the parameter, summation of xy is 69 minus 5 times mean of x 3.8 times 3.6 in bracket. Then you now square everything. All over summation of x squared is 79, then minus 5 times 3.8 squared. Then bracket, you now say summation of y squared is 78 minus 5 times 3.6 squared. You can see how I package everything. This simply entails that when you use a good calculator, not a sales-get calculator, a good scientific calculator, compute this, minus it from 69, and get the square of this. Then compute this, minus it from 79, then keep. Compute this, minus it from 78, then keep. Multiply the 2, and use it to divide this. What you'll be getting will be 0.004. What you'll be getting will be equal to 0.004. Then, this coefficient of determination is trying to tell you that the percentage of the total variation of y with respect to x, total percentage of variation of y with respect to x will be equal to total percentage of variation of y with respect to x will be equal to 0.004 times 100, and that will be 0.4%. This is for coefficient of determination and this is for its percentage. Hope you understood the topic. Don't forget to like the video and click subscribe. Please stay safe and obey the rules of the government for your health's sake. Thank you for watching the video. Please turn on your notification button so that you keep in touch